Today, I will be introducing our paper FAMuS, Frames Across Multiple Sources. The motivation behind this work is how can we improve knowledge distillation from large unstructured data, specifically unstructured text, like collections of documents, documents and summaries, and articles and their cited sources. And how can we distill information from these sources into concise representations like knowledge bases. A common knowledge base used in information extraction are templates in the task of template extraction. I'll motivate this with an example. On the 16th of July, 2007, the inquiry was adjourned. In template extraction, we first identify the trigger and pair it with an event from the ontology. In our work, we use the FrameNet ontology, which consists of roles and definitions which constrain what can fill those roles. And these roles are filled in argument identification and classification steps of template extraction, where in this example, we can fill the activity, the inquiry, and the time, the 16th of July, 2007. To further motivate this paper, let's consider we're reading a Wikipedia document about the Lodgendale bypass. And let's say that I am specifically interested in this adjourning event of the inquiry. Now, what I might do as the reader is explore another document, maybe one of the ones cited in the Wikipedia article, and go to a news article that discusses the event in more specific detail. That is the idea behind FAMuS. So we start with a report passage, which is a short excerpt of a few sentences from Wikipedia. Then, with our specific event of interest, we look to perform the first task called source validation, where we ask, is the highlighted event in the report mentioned in the source? And what we look to do is make a positive pair between a report and source document that discuss the same event. For example, in this, we adjourn the inquiry and we halt the same inquiry in the source document. Then, once we have a positive source validation pair, we look to perform our second task of cross-document argument extraction, which consists of filling an ontology template with both the report roles and the source roles. And it looks something like this, where the final template we're left with has both the roles for the report and source, where the roles might vary between documents or increase in specificity or fill roles that weren't filled before. To facilitate this task, we collect a new data set consisting of report source pairs from the MegaWiki dataset. We then use the FrameNet ontology to use situation types, where a situation is an event, state, or process. And we collect 255 situation types from the FrameNet hierarchical trees based on inheritance. With these 255 situations, we then collect 5 positive and 5 negative source validation examples, where a positive source validation example, the event is the same between documents, and for a negative source validation, it is not. For the positive examples, we also perform annotate for cross-document argument extraction. And here, I'll just show a little bit from our mturk experience, where we had 3 mturkers first annotate the event type, and then annotate whether the event is the same between the documents. Then, once we annotate the source validation, we do the cross-document argument extraction annotations, where we annotate the role fillers for the core roles from the FrameNet ontology, as well as the roles for time and place. To perform the source validation task, we introduce a variety of baseline models. The first and simplest baseline that we introduce is a lemma baseline, where a source document is valid if the trigger of the event from the report text is found in the source document. So if I adjourn my inquiry in the report, I must adjourn the inquiry in the source document. We also introduce a fine-tuned long-former model to perform sequence classification on a concatenated report and source text, where it just looks to either say yes or no based on the context. And we, of course, use large language models with four-shot in-context learning prompts to also perform the source validation task. Here, we provide the initial results of the source validation models. As you can see, the language models are not as strong as the lemma baseline for the source validation task, while the long-former model slightly outperforms it by 5 F1 points. We look a little deeper into these results and explore them based on the document length or the number of tokens in the source document. And here we get some interesting results. The most interesting one is that at the smallest context size, the ChatGPT model actually outperforms every other model and the lemma baseline. However, as the document length increases, the performance of both of the language models decreases, and the performance of the long-former model is relatively stable once it gets to large context lengths that it's very familiar with. We also perform cross-document argument extraction in different settings. The first setting that we perform it in is the report setting, where we take the report text with the tagged event and the event type, and we look to fill the role fillers for the report text. This can be considered as traditional document level event extraction, as we have a few sentences and we're just extracting a template based on that. Then we have the source setting, which is the true cross-document argument extraction setting, where we take the report text in the tagged event, the source text, and the event type, and we look to fill the roles for the source text based on the tagged report event. And since the report setting is normal document level event extraction, we'll only focus on the cross-document setting for the rest of this short presentation. To do cross-document argument extraction, we do two different types of modeling. First, we follow a popular reframing of event extraction as QA done by Du and Cardy, framing our template extraction as question answering, where the question is the event, the role, and the report text with the tagged event trigger. The context where we look for the answer in is the source document, and then the answer comes from the source. We also use a traditional template filling model, iterx, where we provide candidate spans parsed by a FrameNet parser from the source text. Then we look to fill those candidate spans in the template based on the source context. Here are the initial results of the cross-document argument extraction. As you can see, we have two different baselines here. The first I will call the modeling upper bound baseline, which is the iterx gold on that far left. And the lower bound baseline is the report baseline. What the report baseline is we take the original template from the report text, the gold template, and we treat it as a predicted template for the source document. So it's a template that's never seen the source role fillers, but it's the gold template from the report text. As you can see, both language models and the iterx model with predicted candidate spans, not the gold role fillers, all perform below the simple report baseline, with the only model performing better than it is the long former model for question and answering. Then, because we're looking to model the events together, both the report context and the source context, we considered the results by concatenating the report template with the predicted source template. And the way we do this is, if we do not predict a role for the source text that is filled in the report template, we will add that report role to the source predicted template. And here you can see that that greatly improves some of the model performances, as it makes the ITER-X model become our second best performing model, and it improves the performance of the ChatGPT. And the long-former model, which already performed above the report baseline, performs one F1 point better than the previous. Lastly, we'll explore once again the results of these models across varying context lengths. And as you can see, the same trend persists from the source validation results, that as the document size increases in the number of tokens in the context to be considered, the performance of all of the models decreases. And notably, the ITER-X model and the Llama 2 chat model baseline at 0 for any context size above that 2,159 tokens. Thank you for checking out our paper, and I look forward to seeing you guys all in Mexico this June. Thanks.